Welcome back, everyone. In this video, we will go through the process of solving radical equations. By radical equations, we are referring to equations with radicals or roots in them. Here we will be focusing on square roots, but the process is very similar for any degree of root. When solving radical equations, there is a nice step-by-step process for us to follow. Let's go through the steps and then apply them to some examples. The first step is to isolate the root. That is, get it on one side of the equation sign by itself. If there is more than one root in the equation, just isolate one to start out. The next step is to raise both sides of the equations to a power that cancels out the isolated root. For square roots, this would require us to square both sides of the equation. For cube roots, cube both sides, and so on. Next, we will expand, multiply, or FOIL as necessary based on the exponent. We will then repeat the process for any remaining roots in the equation. After we have eliminated all radicals from the equation, we will use whatever method we have available to solve. We might end up with a linear equation or a quadratic or something else, but we should be able to apply our methods of solving to what we have left. Now, in most equations we've seen so far, solving and getting your solution is the final step. However, with solving radical equations, there is an important extra step. We have to plug in the solutions to our original equation to make sure they work. While plugging in is always a helpful way to check our solutions, with radical equations it is a necessary step because we can often end up with extraneous solutions. Put simply, these are extra solutions that don't actually work. Now, let's go through an example to see this process in action. Consider the following equation, the square root of x minus 2 plus 4 equals x. Let's go through our steps. The first thing we need to do is isolate this square root. Get it on one side of the equation by itself. There's currently a plus 4 on this side with the radical, so we'll move that to the other side by subtracting 4 from both sides. That leaves us with the square root of x minus 2 is equal to x minus 4. Now that we have the square root by itself, to get rid of the radical, we'll have to square both sides because that will get rid of a square root. When we square the square root, we're just left with the inside, x minus 2, but now that's going to be equal to x minus 4 squared. Let's go ahead and write it like this so we know to FOIL it. When we FOIL the right side, we'll have x squared from the first, then the outer gives us minus 4x, then the inner gives us another minus 4x, and then the last gives us minus 4 times minus 4 is plus 16. Combining like terms, we get x squared minus 8x plus 16 on the right side. There's no more radicals left in our equation, so we can solve this with whatever means we have left. Because of the x squared term, we notice we have a quadratic equation. Whenever we are trying to solve a quadratic equation, we want to get everything over on one side equal to 0 now. To do that, I'll move the x and the minus 2 over to the right side by subtracting x and adding 2. This will end up giving us 0 equals x squared minus 9x plus 18. Now that we have everything on one side, we can either try to factor or use our quadratic formula. This one is simple enough to factor because of the 1 coefficient in front of the x squared. We'll have something that looks like this, with two numbers being added or subtracted to the x's here. Our numbers will be ones that multiply to positive 18, but add to negative 9, so that will be a negative 6 and a negative 3. Once we have this factored, our solutions will come from when each factor is individually set equal to 0. And solving for x in each, we get the solutions x equals 6 and x equals 3. Now it might be tempting to call this problem solved, but remember with radical equations, we have to plug in our solutions to the original equation to make sure they work. Let's first plug in 6. Anywhere we see an x, just replace that with a 6. And we'll get something that looks like this. Doing the math, we get square root of 6 minus 2 is 4, plus 4 equals 6. Square root of 4 is 2, plus 4 equals 6. And we get something that makes sense, 6 equals 6. So our solution, x equals 6, works. What about plugging in 3 now? Well, anywhere we see an x, just replace it with 3. Doing the math, 3 minus 2 is 1, plus 4 equals 3. The square root of 1 is just 1. Then we are left with 1 plus 4, which is 5, equals 3, but that doesn't make sense. So x equals 3 is an extraneous solution, so we will not list it as one of our actual solutions. For one more example, consider this equation that now has 2 different square roots in it. We are unable to combine these square roots as they are, so let's go through our process again where we just isolate one at a time. I'm going to leave the square root of x plus 1 on the left side and get rid of the square root of x minus 4 on the left by adding it to both sides. When I do that, I'm left with the square root of x plus 1 equals 1 plus the square root of x minus 4. Now to get rid of the isolated square root, I'll have to square it, but I need to square both sides of my equation. That leaves me with just x plus 1 on the left, but something that will have to be FOILed on the right. The left will stay the same, but when I do the FOILing on the right side, the first multiplied together gives me 1 times 1, which is 1. The outer 1 times the square root of x minus 4 gives me just plus the square root of x minus 4. Then the inner, the square root times 1 just gives me, again, the square root of x minus 4. But then the last, I'll be multiplying the square root of x minus 4 by itself, or in other words, squaring it, leaving me with just x minus 4 without the square root now. When I combine my terms on the right, I have an x by itself and a 1 minus 4, leaving me with a minus 3. And then these two square roots are the same, so we can actually combine them by adding them together into 2 times the square root of x minus 4. So I raised my equation to a power and expanded, but I'm still left with a remaining square root, so I'll have to repeat the process and get this square root by itself. To do that, I'll need to move the x and the minus 3 that's over here on the right side over to the left by subtracting x and adding 3. That'll cancel the x and minus 3 on the right, while on the left I have x minus x, which also cancels out, leaving you with just 1 plus 3, which is 4, equals 2 times the square root of x minus 4. To get rid of the 2 that is multiplying the square root, I'll need to divide by 2. Have to do that on both sides. These 2's cancel. And on the left, I'm left with 2 equals the square root of x minus 4. I've now isolated my remaining root, so I'm back at the step where I need to raise my equation to a power to cancel out the root. In this case, I'll square both sides. 2 squared is 4 equals, the square gets rid of the square root, so I just have x minus 4 on the right side. And this is just a linear equation. I can solve for x by getting it by itself. To do that, I'll get rid of the minus 4 on the right by adding 4 to both sides, leaving me with 8 equals x, which I can switch around to x equals 8. So from this radical equation, I just got one possible solution, but I haven't checked it yet, so let's go ahead and do that. I want to plug this value back into my original equation to see if it works. So anywhere I see an x, I'll plug in 8. That gives me the square root of 8 plus 1 minus the square root of 8 minus 4 equals 1. I get the square root of 8 plus 1 is 9, minus the square root of 8 minus 4 is 4, equaling 1. Taking the square roots, square root of 9 is 3, minus the square root of 4 is 2, equals 1. 3 minus 2 is in fact 1, so my solution works. X equals 8 is my solution. Solving radical equations might take some getting used to, but the process itself is straightforward and easily repeatable. It's just a matter of becoming familiar with the steps and executing them. Until next time.